Okay, we've finally made it to our last unit. We're on Unit 8. Unit 8 only has two sections in it. We're going to cover 5.4 and 5.5. And what's nice about 5.4 is that a lot of it is just review. And so what they're really trying to do in this section is kind of reiterate the similarities and differences between indefinite integrals and definite integrals. And so we've talked about finding antiderivatives or integrating, and we've talked about indefinite integrals, where if we have a little f, a derivative, and we integrate it, then big F is his antiderivative, right? It is the antiderivative function that has a derivative of little f. And so big F is the antiderivative of little f. Little f is the derivative of big F. Okay? So an example would be the antiderivative of x squared is x cubed over 3 plus any number plus c, because the derivative of that x cubed over 3 plus c should be the x squared, right? We also talked about a definite integral, where we have limits of integration on top and on bottom, and that's a little bit of a different meaning. We know that the definite integral is really the area underneath the curve of a function, and so you should end up getting a number, not an actual equation. You should end up getting the value of the antiderivative from a to b, which ends up just being a value, where the indefinite integral ends up being a function. So making sure you know the difference between the two. Okay? And so hopefully you've done so many antiderivatives or integration that you know all of these rules. Please make sure that you study all these rules, quiz yourself, just like if we were in class, to make sure that you know all the rules. Because if you don't know the rules, then you aren't able to do any of the problems from here on out. So please make sure that you continue practicing those antiderivative or integral rules. Let's do a few practice problems. Again, a lot of this stuff should be reviewed, so it's kind of nice. Example number 1 asks us to find the general indefinite integral. And so we want to integrate or find the antiderivative of this function. And so inside here, my integrand is my derivative, and I want to find the antiderivative. And so I have an antiderivative using my antiderivative rules of 10x to the 5th over 5 minus 2, and then the antiderivative of secant squared is tangent x plus c. I'm going to simplify it a little bit, and I ended up getting 2x to the 5th minus 2 tangent x plus c. That is my antiderivative. That is my indefinite integral. Okay, let's do another one with a little bit of trig in here. And so we have the integral of cosine theta over sine squared theta. Okay, remember though that there is no such thing as quotient rule with antiderivatives. There is no such thing as chain rule with antiderivatives, and that's what this looks like to me. And so there must be a way to rewrite this problem into something different, into rules that we do know. So think about how you're going to rewrite this problem into rules that we do know. Well, we've seen problems like this in the past where we can take the signs on the bottom and kind of split them up a little bit. And so we can call this problem cosine theta over sine theta times 1 over sine theta, and it would mean the same as the original, right? We haven't changed its value. And so how is that going to help us? Well, we know that 1 over sine is really the same thing as cosecant, and we know that cosine over sine is really the same thing as cotangent, right? And so is there a antiderivative for cosecant cotangent, cosecant theta cotangent theta? Well, hopefully if you've been practicing your rules, we know that the antiderivative of cosecant theta cotangent theta is really negative cosecant theta. Remember, plus c, because we have to have that constant of integration for my general antiderivative. Okay? Let's do one more of these, but example number 3 looks a little bit different. Do you notice how on example number 3 we are now doing a definite integral because we have those limits of integration? And so your answer on this one shouldn't end up being an equation. It should end up being a number, a value for the antiderivative value from 0 to 3. Okay? So let's use our antiderivative rules. Let's integrate. And so I have an antiderivative of x to the 4th over 4 minus 6x squared over 2, and we're going to evaluate it from 0 to 3. That means I'm going to use my fundamental theorem of calculus. I'm going to plug in my upper limit, I'm going to plug in my lower limit, and then I'm going to subtract those two values so I can find the change in my antiderivative from 0 to 3. Simplifying this a little bit, I ended up getting 81 over 4 minus 27, I'm not sure what's happening on the bottom there, minus 0. Getting a common denominator, I ended up getting 81 over 4 minus 108 over 4. And so I got the value of this definite integral as negative 27 over 4. Now my answer ended up being negative. Yours should too. And so what that means is that when we found the area underneath this curve from 0 to 3, that more of the area ended up, remember, being below the x-axis than above. It doesn't necessarily mean that all of it is below. It just means that more of it is below the x-axis than above. Okay?